There you go. The recording is on. Okay, so as today we were just quite seeing more from the introduction of SCM, and we were seeing some terminologies on SCM, right? So from today we'll be talking only about Git as an SCM tool, how we can achieve all those things, whatever we are seeing yesterday. So we'll see more from the developer workflow, what are the activities that we doing, how do you create repositories, blah, 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 whatever it is. So initially, if you try to see the difference as a tool, so why Git is better when compared to other tools, there are various reasons for that. And out of that, mainly if you try to see, there are three things which helps Git to be better than other tools. And that is why it has been quite popularly used across different factors like DevOps engineering or build engineering or just QA, wherein you just have to store your small codes. So the first thing is speed. When I say speed, it is about the workflow wherein you have to create your workspace, then start working onto it. Because assume you have a product which has close to 200, 300 GB of data, then just to download it to your place and start working, it might be a nightmare. Wherein being a developer or a user, you have to just spend close to 30 minutes or 40 minutes just to set up a workspace. When I say setup, it's not a configuration, it's just creating a workspace. So that is a difficulty that you'll be facing in other tools, whereas specifically in Git, things will work like that. Okay, so that is the major advantage. And the next thing is working on parallel branches. So when you go through the branching concept in others, that is in other SCM tools, it's not so easy to maintain too many branches, and it is not advisable. Okay, because they follow some methodology called a single branching methodology, wherein for a repository, they should be having only one branch. That is what system engineers is going to say, or that is what the release management is going to talk. But there are always advantages by having multiple branches with respect to a user. So that feature can be enhanced by using Git, whereas in other tools, it's not so easy. And finally, it is fully distributed. Okay, so these are the major factors why Git is being used everywhere. So whatever we are going to see in the practical classes will be revolving around these three itself. Okay, so now the question comes is that what do you mean by speed, linear is all the concepts, but this term, when you say fully distributed, what do you mean by that? So to understand it a little bit, let's understand the architecture of how Git works. So that would give you a better understanding going forward. So if you see onto the left hand of the screen, so this is an image typically what we were talking about in the last class. So remember I was talking about a server, a client, a workspace, and how things work. So if you take that, that is called as a centralized model because you have a central server wherein you store all the data. Okay, that means in the central server, you will be having all your repositories and all the repositories, files, everything will be present in this particular place. Okay, so that is what we call it as a server, where it acts only to store the changes, wherein at your local place, that is at your laptop, you would have to install something called as client, and through the client, you will create a workspace. Okay, and that workspace will try to interact with the server, wherein for every information that you want to fetch from the server, the client has to talk to the server and the server has to send back the details so that you will work. And that is the same reason when I said you have to create a workspace which is of 300 GB or 200 GB, then all this 300 GB has to be taken from the server and you have to put it here. And this is not the only thing. Even if you have to create a branch, first you have to create the branch in the repository, then through the workspace you have to fetch the information and work. Suppose after doing the changes, if you want to do a check-in or a commit, you have to first do it here, and then that will take it and put it and store it here. So anything that you do is actually going to be interacted between client and server. And due to the latency issues, if your server is somewhere in a different zone and you are working on a different zone, then due to the latency, the network latency, basically that's what I'm talking. So it is going to take a huge time to get the things done. Okay, so that is the first problem when I was talking about speed. Now, the second problem what people would be facing is that when you're working on this kind of model, what happens suddenly if you have to go to some place, say that you have to go to home and maybe for a couple of hours you have to work offline. So in that case, as soon as you go out of the network, that means as soon as you don't have a relationship between this and the server and the client, that is, the client is not talking to the server, then you cannot fetch any information into this workspace, because in order for the client to get the information from the server, it has to be in the network always. So say that you're going to some place on your train or bus, whatever it is, you cannot work anything, right? Because you can just do modifications here, but if you want to store those changes permanently, you are not allowed because you're not in the network. So if you want to share the changes with this person or any other person, it is not going to happen. And again, suppose if you want to share your changes with your teammate who is trying to do a similar feature like you cannot just directly share it from here to here. Logically, it has to be stored in the repository first. How will it store? You have to first contact through the client and go to the server and store, and then through the server, the other person, whatever client that he is working on, he will try to fetch the information. So this way is how you will be distributing your code. But if you're not in the network, even this will not happen. So these are being certain problems from the developers or from someone who's trying to maintain the code would be a huge problem. Okay, so to overcome this, Git has a distributed model. That is the reason we don't just call Git as a version control system, we call it as a distributed version control system. Okay, now talking about that, how does it exactly differ? Okay, so to talk about that, the first thing what you need to understand is in Git, there is no server and client concept. Okay, so that means you don't have a server separately. Okay, now the question comes back again. If you say that there is no server, then where are the files going to be stored? Or where are the repositories going to be stored? So in Git, each workspace that you create will internally have a repository, which means if you install Git in your laptop, it itself acts as a server and client wherein I can directly create a workspace, and in every workspace that I create, it will have its own repository. Okay, so in that case, if you as an user, we will be having the workspace wherein we will be working, and in that we will be having a repository for us itself. So if there is some other user who will be working, then he will be having his workspace, and inside this workspace he will be having a repository specific to that. So like that, each workspace someone creates, there will be a repository inside it. And again, it is not that only one workspace has to be created by user. A user can create many workspaces. So now, because of this, every workspace has its own repository. Logically, all the changes, all the branches, whatever you create will be in that workspaces only. So that being the case, whatever problems that you're facing earlier will not be here, or you can overcome. So if you see that you are owner for your repository, because If you do some changes, immediately it will get checked in. Why? Because unlike here, you are not going to store or check in into a separate server. You have the repository in your own directory on which you are working, right? So in that case, any changes that you want to store, you are storing it permanently in your own workspace. And second thing, if you want to create branches, you don't have to ask anyone to create in the repository, then come and use. You have the rights for yourself. You can go ahead and create as many branches as you want in your local workspace that has a repository. And then suppose if you want to share the changes between others and you're not in the network, things will still work. Why? Because if you are going outside the network, it doesn't matter because you are carrying the complete workspace and the workspace itself has a repository. So you have the rights to share to whom is that supposed to be going into. So in that case, any point of time, you can share it with any user directly. Okay, as long as internet is working, it should be pretty much enough. So you don't even have to worry about having to be in the same network. Fine. Now, in the same concept, if you understand it, it is good and advisable that you can share the changes between different users. But when you go as a corporate, it is not a standard because it is not only for certain policies. It is always better that you don't just share between people directly. So for that purpose, what you can do is you can create a workspace or you can create a repository only for sharing purpose. Okay, so it is going to be just the same workspace as you are going to use it differently, but you will be creating a server, sorry, not a server, you will be creating a workspace or a repository which will be used only for sharing. Okay, and we will call it central server, wherein no one is going to modify anything in that. Instead, we are just going to using it only for storing and sharing the purpose, wherein the local workspaces what each user will have, there they will be doing the modification, and once they have done the changes, if they need it to be shared, then they will first put into the central repository, and then from the central repository anyone else can take. So now it will be acting as a normal policy in any other place that you wanted to work. So in the same way, if you want, you can share changes between the users directly, or you follow the policies wherein you first share the changes to a central server or a central repository, and from there anyone who wants to take the code will be taking. So this way you can have a complete distributed environment so that you can work both the ways. So this is the advantage, and this is what we call it as distributed version control system. Are you guys getting it? Because this is what you need to understand, because going forward, unless and until you don't understand this, it will not be easy for you to get other things.
Hello.
Any? Yes.
Hello, sir. Actually, I want asking about the distribution. This server computer is there. So, if there is any server computer, then why it is called the distributed? But it's a centralized, no?
No, there is no server here. What I'm trying to tell is, instead of
Yes.
storing everything in your own workspace, now as a company, in a product, there will be hundreds of people working. Okay. Now, every workspace that you create will have its own repository. So you have the freedom to store all the changes in your local computer itself. But as a company, if you see, you cannot store everything in your place. So in order to share it with others, it is not advisable to share directly from your laptop to everyone. Because what if the other person deletes your files completely, then it is gone. So for that reason, what we will do is we will create one repository and we will keep it in some separate server. That's it. It is not like this is a server. It is just, instead of keeping this repository or the workspace in your local laptop, we will keep it in some separate server which has access to everyone, and everyone can access it from there. So if a user wants to take a change from your place, rather than taking it from your repository directly, you can first create a central repository which will be present in some other server. That's it. Wherein everyone has rights to access it. So what you will do is you will do the changes locally, store as much as possible, and when you feel that this has to be shared with others, then you push the change to this central repository, and it will be stored here only for sharing purpose. And any other person who wants to take the code, he will be taking the code from here and he'll be modifying it. And at the same time, when he has done his changes and when he wants to share his code to others, he will be sharing only that code, whatever he is interested to share. How? Again, he will push to the central repository. So there is no concept of central server. It is just the repository which is present in a different server.
Okay, sir. Okay, sir.
Getting it? We will
Y-
work on the
Yeah, yeah,
practicals, you will understand. So it is not mandatory you should have in a different server. I can have this repository in my own laptop itself, wherein I will use it only for sharing. So that is what we are going to do in practicals. We will have one repository which will act as a central repository. So when I say central repository, what is it? It is used only for sharing changes and storing changes. You will not be working on it, wherein we can create local workspaces like this on which we can directly do some modification. Okay. Any other question? Is that clear?
okay, sir. Okay. Yes, 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 it's clear.
Okay. So let me just repeat it quickly. You have to understand this. Every workspace will have its own repository. Okay. Keep it in mind. Fine. Now, moving forward. So if I say that every workspace will have its own repository, now I was saying that you have 200, 300 GB of data. That means, is your repository going to be 200, 300 GB of data? And when I say repository, repository is not only going to store your files, it is also going to store what and all information that you have modified, that is the commit information, right? Every time you do a check-in, you have to create some reference, right? All those reference, all the metadata, everything. So does that mean that every time you modify the file, is it going to take a backup of this file? If that is the case, then your workspace or your repository is going to be in TBs. It is not going to work out, right? So say that you have a file with 10 lines. Anup comes, he modifies two lines. There will be one version or one commit created. Then Nagesh comes, he modifies two lines. Then there will be one more commit created for that. And then Rajesh creates one commit. Similarly, Prithvi creates a commit. So now each user creates one commit. Now, does it mean that you will be having 4 copies of the file? Logically, if you do that, then it is not going to be working out because it is going to be taking huge time and space. So the concept how Git stores everything is in something called as snapshots. Okay, so in general terms, what do you understand by snapshots? Don't just think only from IT or in generally. Have you heard anywhere this word called snapshot? What do you understand by that?
There is an app called Snapshot, I think.
Not exactly to Git. Generally, have you heard anything about snapshot anywhere?
I, yeah, I think the snapshot is called as image.
Uh,
But
I,
I can say,
I didn't get it. Can you please come again? Sorry, someone was saying something about Nagesh.
Yeah,
Yeah, what was that?
yeah, a snapshot nothing but a picture or
Yes,
image.
yes, something like that. Now, what does it represent?
It represents some type of data.
Okay, okay. Anyone else?
It's like exact copy of the data, exact copy.
You're close enough.
So does Prithvi, even Prithvi message saying that.
Exactly. So if you take your Windows, generally it takes a snapshot. Have you ever heard of data recovery? Something crashes. If they ask you to, can you get me back all the data? What they'll say that I'll go to the snapshot which it has created when you're working last time, and from there I will get all the data. Okay. So what in general terms snapshot means? It represents some data of a particular time. Okay, so no matter what you're working on, snapshot in general means that it represents a data which is there at a particular time. So when you say, how can it say that this was the data that you had? So logically now I'm asking you a question, say that if you say that uh, I have this much with me in any content, how will you tell? So unless and until you know what you had before, you cannot just now tell that I have this much, right? So in the same concept now, if you say that you had a file and you have some data in it, and if you're saying that I have modified 2 lines, how will you say that you have modified 2 lines unless and until you know how many lines were there before that? Logically, you're getting it. So that is the same concept Git works. Okay, so what it does is every time you try to modify something, it will try to take the delta, in the sense the difference between what you had previously and what is that you're trying to do, or what is that you're modifying now currently. So it will try to take the difference between these two and take a snapshot of it and store. So logically, it will not be storing the entire file for every commit. Instead, it will be storing only the delta between what you modified earlier and what you modified now. So how it will be pointing it is that any point of time, if you want to refer, you will be just referring only to the delta, wherein for each commit that you do, you will be storing only the differences. So for Anup changes, whatever only 2 lines changes, it will be stored as a snapshot. For Rajesh changes, it will be stored as a snapshot. For Prithvi's changes, there will be stored one. So like that, for each and every changes that someone does, there will be a snapshot corresponding to the difference between what they had earlier and what they are currently doing now. So in that way, you won't have to store the entire file, but only the snapshots. And that is why the space that is going to be taken is less, and also the operations, whatever you perform using Git, will be faster. Okay, please stop me in case if you have any doubts or you're not understanding. Okay, okay, now, so a little thing what you need to know about the commit. So now I said that when you try to submit some change into the repository, that is when you do some change and submit it back to the repository, Git stores it as a version, wherein the version is nothing but commit, or in Git terms we call that as commit. So every time you put some changes back into the repository to store permanently, we call it as a commit. Okay, and now for every commit, there will be one ID to represent it. Okay, so how will you find out who did this modification? So for that, it will create a ID. Now, it is not a straightforward way in any other tool, because if you go to any other tool, generally the ID will be in terms of numbers and it will be increasing. So which means, like, say when the first user submits one change, it'll be commit 1 or it'll be ID 1. The next time he does, it'll be ID 2, then 3, 4, so that you can know that how many commits have been done. But in Git, it is slightly different, because in Git, whenever you submit a change or when you commit a change, it is going to create a ID, wherein the ID is going to be a 40 characters or 40 long digits. Now, when you say what is that 40 long digits, Git uses something called checksum. Okay, so using the concept of checksum, it generates a 40 long digit. Now, if you ask what is this checksum, to put it in simpler words again, it is a tool which is available in Linux or Unix, which helps to generate some binary value equivalent to the data that is present in your file. So you might be having any kind of file. So it represents some data, all right? So in order to represent it quickly on what data you have, this tool called checksum will generate a number. Okay, so at any point of time using this number, you can identify what is the content on it. No, it is just going to refer that this data represents to this value. Now, why this checksum will be used in general cases? Generally, if you're trying to share some file, like you are sharing your product with your customer, and you will give some location to download, right? So over the network, what will happen when they are trying to download, some data might get corrupted. So in that case, generally they will be generating something like checksum value, and they will give it to the customer. So for example, when I'm trying to upload a file or upload a product, I will try to generate the checksum, which will say for this file, this is some number which represents it. So I will give the same number to the customer. So when the customer is downloading the same file, he should be logically getting the same number as what I have got, because the data whatever that we have put in the file is the same thing what even he's downloading. So by this they can compare. Suppose when the checksum, using the checksum tool, if the customer is trying to generate the value once again, and if the data is corrupted, then obviously checksum number is also going to be different. So using that, we can compare if there is any difference between the data what we have given and what he has used. So we use the same concept here, but for a little different purpose. So it is because every time you store something in Git, it is security is very good, because even though if you change one small dot, it is going to clearly track it. And that is why checksum is used, because now every time you modify something, you will be getting a new checksum. Unlike other tools, you cannot just mess up the data easily, saying that, oh, I can easily delete some data, no one else will know. Because here it uses the concept of checksum. Even if you change the timestamp, you will be considered as a new commit that you're trying to modify the file. Okay, that is why it is quite popularly used. So it uses the same concept, wherein every time you try to commit, it will be generating a 40 long digits or 40 characters, which represents whatever changes that you have done. So internally, if you see that commit ID, it will be nothing a hash value, as I said, or you can simply refer to as 40 characters. Now, what and all does hash, or what and all is this commit ID going to contain and represent? So mainly the commit ID depends on four factors when it is generating. So for the first thing, what it does is, it is the data what you have modified, wherein it is not just directly going to say the data, but it is trying to take the snapshot with with this regarding what changes that you have done. So as I said, every time you do some changes, Git is going to take a snapshot. So when you try to commit, that commit, first thing it is going to refer to the snapshot, what it has created for your changes. And then it is going to also depend on certain other factors, like who is the author or the user who is modifying it, who was the initial person who created this file. You have to give certain messages as a comment message, and also the timestamp whatever on which you are modifying. So like this, you will be storing all this information. With respect to that, a commit ID will be created. Okay, so commit ID, each commit ID will be representing all these things. So it represents a snapshot, and who modified, when modified, what and all you modified. Okay, so this is what you need to understand it a little bit with the Git commit ID. Okay, don't get confused too much. It's just for logical understanding. I'm just telling you. So we have next two slides which are more important, and after that we'll be getting into practical on what we were just seeing right now. So before going further, you need to understand what and all you will be having in your Git workspace. So logically, I was telling some time back that when you create a workspace, you will be having a repository with each workspace, right? So in the same terms, every time you create a Git directory or Git workspace, you will be having three areas within that workspace. Okay, so whenever you create a Git workspace, you will be having three areas in that workspace. So what and all are they? So the first thing is called as working directory. Okay, so what do you mean by working directory? So working directory is the directory on which you will be physically seeing the files and you will be modifying the files. So anything that you see in your directory and anything that you modify in that place is what we are going to call it as working directory. Okay, and then you will be having a separate area to store everything. So that is what we will call it as Git repository, or there will be one more directory within your workspace where you will be storing all the changes, that is snapshots and everything permanently, and that is going to act as a Git repository. Okay, now what about the third area? So in Git, it is not that whatever changes that you do in your working directory will be directly stored into the repository, wherein it has to go through a buffer area calling staging area. Okay, so whatever changes that you do will be committed in two steps. That is, first, you have to take the changes what you have modified in your working directory and put into the staging area. And once you put into the staging area, the Git will take the snapshot. Okay, that is the purpose why you need to first push the changes to staging area. And once you have put the changes into the staging area, from there you will be doing the commit, or you will be doing the check-in, which will store the changes permanently. So these are the three areas wherein working directory is the place where you actually modify everything. And then you have a place called staging area, which is nothing but a buffer place inside the repository. It is not a physical area. It is just a buffer which is available in the repository. So any changes that you do, you will be pushing into the staging area. And from the staging area, you will be actually committing it into the Git repository. Okay, so these are the three areas that will be present in your Git workspace. So now, if you see how you will be exactly working is, so anything that is present in Git, it can easily identify. So logically, when you create a new workspace, so you are not going to create everything from the scratch typically, right? So what you will be doing is, if you remember, I said you will be having a central repository. So you will get a copy from the central repository so that you will have all the exact files and a copy of the repository similar to the central repository. So once you have your workspace, you can start working on that workspace locally. So when you're doing it, like I said, typically you will be having a working directory and you will be having a Git. So logically, whatever changes that you have in your working directory will be present in Git directory also. So any changes that you try to do for an existing file, Git will automatically understand that you have modified. That is because it already knows about some content, what it is being maintained in the repository. So now if you just change one more line or add one more line, then Git will say that with respect to what I have stored, you have modified one line or two lines. So it will say that you have modified this file. So that is how it is going to track each and every file that you have stored in the repository. So when you're trying to put a file very freshly, that is, you are trying to create a new file and put into the repository, the very first time it is going to call it as untracked. So when you say untracked, it means that the repository doesn't know anything about it. That is what it means by untracked. Okay, so when I say tracked, what does it mean? The repository knows about this file. That is what it means by tracked. So logically, when you're creating the file for the first time, it will be untracked. Okay, so now once the file which is being created in your working directory is untracked, as soon as you put into the staging area, it will be called as tracked. Why? Because staging area is maintained by the repository. So now, since you have put some files into a place repository understands, now the state of the file will be changing from untracked to tracked, wherein in the track, what kind of file it is? It is a modified file because I am tracking some content, and with reference to what content I have, you have modified something. That is why it will call it as modified or unmodified. Okay, so once you store a file into the repository, now from there it will clearly say whether a file is modified or not modified. So you don't have to say much thing here, wherein if you ask this Git to give me the status, it will clearly tell that with represent to what content I have, you have modified 1 or 2 files, and that is what it is going to stare. So storing will happen in the same way, wherein if you don't modify anything when your workspace, that is when you try to create a new workspace from the central repository, everything will be same. That is whatever is present in the Git repository will be same as in the directory. So in that case, the files will be in unmodified. As soon as you do some modification, the file will get turned into modified state. Wherein, how does Git know that it is modified? Because it knows about some content about your file, wherein you have added some new line. So Git will immediately say that if I see what the data that I have in the repository, you have some additional line or you have some modified line. So that is why I considered it as modified. And once you have the modified file, you will be putting into the staging area. And once you put to the staging area, you will be doing a commit. So once you do a commit, the file will get turned into unmodified state, because as soon as you have the data from here to push to here and from here to here, it is the same data what you have here and here now. That is the reason Git will say the file has been unmodified state. Okay, so this is the life cycle of a file, how it goes through, wherein if it is a fresh file, it will be called as untracked because it doesn't know anything about the file in the repository. Okay, so are you guys getting until here? Any questions? Nagesh, Rajesh, no doubts? Okay, fine. Now, moving further. So until now, we were just seeing some terminologies. So let's get deep diving into the subject. But before that, there's one confusing question which comes to everyone's mind, because wherever you see from the job profile or in the internet, people call it as hub, GitHub, GitHub, GitHub. And when I said there's only one thing in Git, you don't have a separate installation for server client. There is nothing like that. So then, what is the difference between Git and GitHub? Is there a difference? Is Git separate and GitHub is some different version of Git? That is what the question everyone would have in mind. So to just clarify that, GitHub is nothing but a place where you store your central repository. So instead of storing everything in your own laptop, like I said, you will create a central repository and you will be storing it in some place, right? So that place where you store is nothing but a GitHub. Now, since Git is being more open source, so you can create your own open source code and you can share. So in that case, a place called GitHub where you can store all your central repositories and share it with others. So logically, If you are storing some files which can be shared by others, then you can use this GitHub. If not, in companies, you will not be sharing the code with outsiders. So what you will be doing is you will be having your own server in which you will be maintaining all this repositories. So in that case, that server where you maintain everything will act as your GitHub. Okay, so that is the only difference. So GitHub is nothing but a online place where you store your repositories.
Hello, Adam.
Yes, can you hear me? Hello? Hello? Hello?
Yeah, your voice is audible.
Yeah, was there any question?
Hello.
Nagesh? Hello? Nagesh, you had some questions?
Hello, Adam.
Yeah, Nagesh, I can hear you. I think there's some problem from your side. Others are able to hear. Hello? Let me stop it for. Okay, Nagesh, you can hear me now?
Yeah. Yeah.
Okay, cool. All right. So with that doubt clarified, we'll proceed further. So, okay. Now, how do you install Git? It's quite simple. You don't have to break your head for that. So just go to Git site or just say Git download, and you'll be having installer specific to each operating system. So since I am working on Windows, I'm just going to install it. So the advantage of using Windows here is, if you see generally, if you install anything and if you want to work from command prompt, because since we'll be working from a user level and the administrator level, it'll be everything on command prompt. So we don't want UI specifically for this. So in that case, either you can work using your Windows command prompt, but it is not so convenient because majority of the times in the production you will be working on Unix. So there is no difference between the commands what you are going to type in Windows and Unix. But when you install Windows, it has a feature wherein it installs a additional bash prompt which will be equivalent to Unix commands. Okay, so that is the difference between Windows and any other installation. So now any Unix command that I want to type, I can basically type here and it'll work. It's not like a full-fledged Unix, but it gives a prompt which is similar to Unix. So it'll be easy for us to understand even from the classroom when you're trying to work, it'll be both the same. Okay, so all you have to do is just download this, double click and install. Okay, so it is not going to ask you anything. So just keep pressing next, 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 and it should be done. And once installed, you should be seeing a bash prompt like this, and use this to work for your Git commands so that it will be easy for us to have a similar environment as we have in the Unix background. Okay, so fine. Now, once you have downloaded and assume that it's installed, just ensure that it's working fine by checking the Git version. So right now, if you see, I have 1.9.5 version which I've downloaded and I'm working currently on that. Okay, fine. Now, before getting started, there are some configurations which we have to do. So when I say configurations, it's not so huge and all. So there are certain data which you have to store. Okay, so if you remember, and I was explaining the commit ID, I was telling that every time when you do a commit, it takes a reference of the author, it takes the reference of who modified specifically, so all those data. So for that things, we need to store who is the person that is trying to work, what is his email ID, and other information about the user. So in that way, the configuration that you are trying to do in Git, you can do it locally or globally. So what do you mean by locally and globally is, if you want, you can do configurations for each workspace or each repository. That means now if we create one repository, I can set some configurations only for that. And then if I create one more workspace, again for that I can set configuration. But logically that is not the best practice, because on a laptop or on server, any amount of changes that you do using any workspace or any repositories, it should be having a single configuration, because it is the same user who will be doing all those things. So for that purpose, we will always be setting the configurations globally. Okay, so how you do is, there are certain things. So the first thing is git config will give you the options to basically modify everything. Okay, so if you want, what you can do is you can just say git config -list, and it will give you a default list of configurations that has been done. So okay, now if you see, these are some configurations by default it's been set. So this will say which user, from where you're using, what is the color of the background of the screen, all those configurations that you can set, wherein our interest is not on all those things. So what we are interested to modify is, we are trying to set few configuration values with respect to the username, email, and some information about default push that I'll tell you a little later. So first thing what we'll do is we'll try to set the username. Okay, so when I set the username, okay, now then once the username is set, I will set the email. Okay, I have set this, and then after that there is something called push.default. Okay, and I'm going to set it as simple. Now, don't worry about what is this push default. I will explain you. There's some particular concept when we work on that. I'll let you know. But other than that, we have set these values. If you want to cross check whether it has been set properly, you can run the config list and it will show you that, okay, you have set this value, that whatever that you wanted to set. Okay, so now these are the only three things which you need to do. And remember, you will not be doing this always. And why is that? It is because whatever changes that you have to do, actually it will be put into your bash profile or in your login profile. So in Unix, every time when you log in, there will be some environment which is created by default for you. There will be some environment variables, all those things will be created, right? So in that place, the default configuration, the Unix administrator will be putting all this information, or you can add it anytime you want, so that every time you log in, the same data will be taken or the configurations will be set. So these are the only three things which you need to set it up, and it is important. Okay, so once you have set it up, the next thing what you are going to do is we are going to create the repositories. Okay, so let us start from the scratch. So let us see how to create a repository and then proceed as a developer or a user works. So now the first thing you need to know is, when you are creating a repository in Git, there are two kinds of repositories. That is, one repository is called as bare repository and the other one is non-bare repositories. So what is the difference between bare repository and a non-bare repository? So a bare repository is a repository where you are going to store the files and share the files, which means you are not going to do any modifications in it. Okay, such a kind of repositories are called bare repositories. So logically, all the central repositories are bare repositories, where you are not going to modify anything. You are just going to store the changes and share the changes. Okay, so the opposite of that, what is it? Non-bare repositories. So non-bare repositories are those repositories where users will be actually modifying all the changes, and that is where you can see all the files physically. So typically non-bare repositories are nothing but the local repositories or the user repositories where they will be working. Okay, so you have to be very clear. Central repositories are bare repositories, where in the bare repositories you will be only sharing the changes and storing, and you'll not be doing anything. Whereas in a non-bare repositories, which are nothing but the local repository or the user repositories, that is where you will be modifying all the changes. Okay, so typically, as the workflow, what is the first thing we need to do? First, we need to create a central repository, so that from that central repository, we will ask all the users to get a copy of the repository, do their changes, and whenever they want, they send the changes back to the central repository and store. Okay, so how do we create a central repository, or how do I create a bare repository? So git init is the command which we use for creating a repository. Okay, and in git, uh, all the commands are quite very straightforward. Okay, just by looking at the name you can say, and that is how internally it is going to be. So if you see here, init stands for initialization. So what is that you are going to initialize? You are going to create a repository. So okay, so I'm gonna remove few things. Okay, so first thing what you're going to do is I'm going to create a directory. Okay, so I'll say central.git. Let's go to central.git, and git init is the command which we will use to create a repository. And now what kind of repository we are interested to create? We are interested to create a bare repository or a central repository, right? So we will have an option passed called bare. So that means you are creating a bare repository or a central repository. Okay, now typically everything will be directory only. Okay, so that is the reason when you are creating a bare repository, you store the directory name with an extension called .git. So by that you can clearly identify that this repository is a bare repository, or this is a central repository which is used only to share the changes and store the changes. Okay, so wherein others it will not be having, that means all the local workspaces will not be having those changes. Okay, fine. Now, once this much is done, then the next thing what we need to do is to create a user workspace or to create a user repository. Now, from where will you create a user repository? With reference to this central repository what we have created. So how do you create this? Simply use a command called clone, wherein clone will create exact copy of a central repository. So the options what you have to pass for that is you have to say git clone and then the central server or the central repository name followed by the local repository name. Okay, so now, so if you see, where am I? We are inside a directory where we have the central repository. So we will say git clone and then followed by the repository name. Suppose if you were working on the central repository which is present in GitHub or which is present in some other remote server in your company, then typically you will give this path like this. You will say like that. You will give the reference like this. Okay, but now if you see, I have the repository in my own directory or in my own server or local host where I'm working. So simply I can remove all these things. And also if you see, I am present in the same directory, right? So what we can do is I can just say here and I can create a new workspace out of it. So, okay, so now what is that we have done? We have created a new workspace called new00 from a central repository. Okay, so you have new00. So now if I go inside it, okay, what is that you're seeing? Actually, you're not seeing anything. Why? Because the central repository was an empty repository. So from that empty repository, I created a clone. So obviously, even my workspace is going to be empty. Okay, so wherein we just created one clone or we created one local repository. And what kind of repository is this local repository? It is a non-bear. Why? Because we will be doing all the modifications here. Okay, now let's go ahead and try to add some files and see how it is going to work. Okay, so now I'm going to create a file. So say that I will create a file called one.java. Okay, one minute, just let me have a water, just 2 minutes. Okay, yeah, so as I was saying, we will be, okay, so what did that, we created a file. Now, once we have created a file, now if you use a command called git status, okay, so it will tell you what things that you have modified with representing the workspace and the repository. Okay, so can you see this? What is it saying?
Yeah.
First thing, it is saying that it is an untracked file. Okay, so what do you mean by untracked file? Untracked file is something which the repository doesn't know. That is what it means, right? Okay, so now Git is clearly saying that it doesn't know anything about this file called one.java. That is why it is saying it as untracked files. Okay, now what is our need? That okay, I have created some file. Now I want to add it to the repository or store it into the local repository first. So now how will I store it? So if you remember, committing or checking in the file or storing the file into the repository happens in two steps. That is, first you have to put the changes into the staging area, and from the staging area you will be storing it into the repository permanently. Okay, so how do I put the changes into the staging area? So in order to put the changes into the staging area, you have to use a command called git add. And what is that you're trying to put into the staging area? This file called one.java. Okay, so now you have put the changes into the staging area, which is present in this workspace. Now if you run this git status command once again, so now you see it is not in the red color or it is not saying it as tracked. Why? Because staging area is being maintained by the repository. So now it knows that okay, there is some file you are asking me to add, but does it have any information about it previously? No. And this is the first time you're trying to put the changes into the repository. So it is clearly saying that it is a initial commit, or it is the first time that you're trying to store this file into the repository. Okay. Now, once this is done, the next step is to commit it exactly. So I'll just clear this. Okay, so how do you commit it? So to commit it, we use a command called commit. And when you're trying to commit, you have to always follow this practice of using an option called -m, which means a commit message. Okay, so we will say initial commit, or I'll say first commit, first check-in. Okay, and first check-in of whatever changes that you have put into the repository. So we have stored the changes. Okay, once that is done, now if you say the git status, it is going to say clearly that there is no changes that is available. Okay, so why? Because whatever changes that you have done, you have stored into the repository. That is why whatever contents the repository is having, you are having it in your working directory, and there is no changes between that. Okay, so like this, now say that I will add one new line to the file. Okay, so I'll say line 1. I'm just adding some content. Okay, now if you see, you can see a difference. That is, Git is trying to say that it is finding some modifications. Are you getting it? So that means typically now it is not saying that it is untracked files. Why? Because you have already stored some content of the file and you have stored it into the repository, right? So that is the reason now it is clearly saying that you have some file which is modified, and that is what it is trying to say clearly, that it is modified because the file has been started to track in the repository. And now how do you commit the changes? So commit will happen in 2 steps. That is, first you will say git add and the file name. So now if you do it, you see that the color will get changed in green because now the files has been put into the staging area and it has taken the snapshot. Okay, now once that is done, the next thing what you have to do is you have to do a git commit and -m followed by, I'll say, second check-in. Okay, so once you have done this, if you see the git status now, it is going to say that there is nothing to commit, your working directory is clean. So this is how you will be doing a modification, and every time you do a modification, you will put into the staging area and then put into the repository to store permanently. Okay, now if you see how many times did we do a check-in or do a commit, there is 2 times that is we did. Now how is that it is going to store and track? If you remember, it is the commit ID. So now in order to see the commit ID, you can simply say git log, and git log will display you all the changes or all the commit IDs that you have done in the current repository from the latest order to the oldest order. Okay, and now if you see, what is this? This is a 40 long characters which is representing a commit ID what you did just now. And if you see, it is not so easy to identify what you have done just by looking at the number. That is the reason we give all this details about who is this author and whatever the configuration that we have done and this comment. Now using this comment, I can try to identify that, okay, I think this is the second check-in I did, some comment that I've done. Okay, this is the first check-in, and who did it? This person. What is his contact ID and when did he do at this particular point of time? So like this, you can try to refer, and this is how Git will be storing all the commits that you try to put it into the repository, wherein it will be displaying in the latest order to the oldest order. Okay, now when I was talking, so typically we are trying to do changes to file and you will be doing it, but in practical you might not be doing changes file by file. Why? Because there might be multiple files on which you want to modify. Now say that a developer is trying to do some bug fix or some enhancement. He will not be just modifying in one file. the source code can be multiple files, and then the source code can depend on some other libraries or some other dependent files, then he will be modifying them also. So within the same product, you might be working on multiple files. So typically, are we going to store file by file into the repository, or are you going to do commit file by file? No. The difference in Git is that whatever commit that you do, you can do it with respect to a set of changes. So when I say set of changes, you can take a group of files, whatever that you have modified, and you can store all the changes at one shot as a commit ID. So that rather than representing one commit ID for one change in a file, you can refer a commit to a changes that you have done for a group of file, that is set of changes. So every time if you see in Git, it will always be representing a set of changes, okay, or we simply call it as change set. So how is that we are going to do? So now let us take the same example of modifying one more file. So what I'll do is I'll first modify the existing file. I will add one more line. Okay, sorry. So now if I just print the content of the file, you see I have added one more line. So now quickly what we'll do is we'll create one more file called 2.java. And now if you say the content of 2.java, it is there. Okay, so now see what happens. Now if I say git status, you see it is clearly saying for the first file, it is saying it is modified, whereas for the second file, it is saying untracked. Why? Because it is a new file. Okay. Just a minute. I think someone is on my door. This knocking. Just a minute. Hey, sorry guys, my bad. Actually, I locked my house gate and I had the keys kept inside, and I forgot to share it with others. Anyway, sorry for that. Sorry for the interruption. Okay, so where was I? Hmm. Yes, so I was saying that we will be storing the files as a set. So now we have modified two files. Now, in order to add it to the staging area, how is that we have to add? Initially, I said you are going to add by file. So, but Git is used to store a set of changes. So what we can do is instead of passing file by file, you can simply use a dot, where dot represents the current directory. From that directory, whatever changes you have done, you take it everything. So if you see, where am I am in the parent directory of this workspace. So typically everything that you're going to modify within this workspace is going to be picked up for staging. Okay, so that is how you will be doing going forward. Instead of doing file by file, you just simply say git add dot, so that it will take all the files into consideration. So now if you see, it has taken both the changes and it has created a snapshot. So we cannot see logically what is the snapshot, but you can see the color changes, and you see it is clearly saying that this is a new file and it is a modified file. And now if you try to commit it, okay, so it has done. So now let me clear, and if I say git log, you see you have created a new commit ID which is corresponding to this. Okay, so like this, for each change or each change set, what you do, Git will be creating a new commit which will be represented by a 40 long characters. Okay, so now this is how you will be doing it. Now in the other way, so going back to the slide which I was saying, that in Git you have three working areas, or three areas that I said, right? What and all are they? The first thing is working directory, then the staging area, and then the repository. Okay, so typically staging area is a buffer place, so you cannot see it. But other than that, where is your working directory and where is your Git repository? So to understand that, now what is that you are working? Currently, I said working directory is the place where you can physically see the files and modify the files. So logically, this is the place where we are trying to see the files physically and modified. So now that means this new 00 is the working directory. Logically, that is the workspace, and along with the workspace, it is also acting as a working directory. Okay, that is fine. Then where is the Git repository? Where is the contents of the repository which is being stored? All those things, when you said you did all these things, where is it stored? Any idea?
In GitHub,
Who was that?
Rajesh.
No. I said GitHub is only when you want to store it. Other than that, everything that you do is in your local place. GitHub, forget about GitHub for now. Okay, whatever you're going to do, everything is in local place only. GitHub comes only when you want to share something with other users and store it. But until then, what did I say? I said if you create a workspace, you will be getting a repository along with it, right? That is what we saw.
Yes, yes, yes.
Now I said you have three, wherein everything together is your workspace. Now new 00 is a combination of all these three, wherein inside this working directory is nothing but the top level directory where you are working. So my question is, where is this Git repository? Logically, it should be present inside the new 00, correct? Yes or no?
Yes,
Yeah, now the question is, where is it?
yes.
Inside .git repository, .git
Hidden.
folder.
Yeah, exactly.
It is hidden. So
Yes. So
not
in Unix, if you put a dot before a file or directory, then it will be in a hidden mode. So you can use an option called -a with respect to ls, then that will show you. So now if you go to this, so this Git or the .git directory is the repository where all those changes, whatever you've done, is being stored. You have the staging area here, you have the metadata information here, and all those snapshots, whatever you're creating, will be stored here. Okay, so the point here is, why is it hidden? Because if it was directly as a directory here, suppose like say you had 1.java, 2.java and git directory, typically it is visible to the user, and sometimes by mistake if you're trying to delete, and if you delete this, then everything will go off. I mean, files will be present, but if you delete this directory, then this directory is going to be a normal directory which is available in your operating system, or it is available in the Unix. The only difference that it makes is this Git directory. Okay, only with the help of this Git directory, when you run some Git command, it will try to understand. So if you don't have this, that is, if you don't have all this configuration files, it is not going to understand. So that is the very reason it will be just putting it as into a hidden format. Okay, so now be clear that any changes that you're doing in your workspace is going to be stored in the same repository, and that repository will be present inside this .git folder of the workspace. Okay, now new 00 in a bigger picture is your workspace, wherein anything within that which you can see physically is going to act as your working directory, and the .git is going to act as your Git repository. Is that clear?
Yes.
Okay. Now, I was telling you some specification about modification and everything. Okay. Now, so once you have done the changes, so until now, what is that we have done? So we have done the changes in our local workspace. Suppose if you want to share the change with others, then what is that we have to do? We have to logically put the changes through the central repository, because we forgot that we have a central repository, right? So now what we have to do is, let us put the changes into the central repository. So typically the central repository can be present in your own place, but it will not be present in the same place. It will be present in the GitHub. Now, if you have to share the changes, how will you do? So for that, we have to use a command called git push. So when I say git push means it is going to take all the changes what you have done in your local workspace or the local repository, and it is going to share it in the central repository, or it is going to put into the central repository for the use. Okay, so now if you use this command called git push, so what it would have done is it would have taken all the changes and it would have put into the central repository. So now quickly, if we switch between the central repository, okay, let me just clear the screen. So now if I go to central git, and now if you say git log here, you see all those changes, whatever that we did in the local repository called new 00, it is available in the central repository. Okay, but first question comes is, let me go to this new 00. What is that we did? I did git push. So now it is saying everything is up to date. Why? Because whatever content that you have in your new workspace repository is the same that is available in the central gits repository. Okay, now did we literally tell that you should put into the central repository called central.git? Did we tell? No, we didn't tell anything. Then how did it directly put into the central.git? It is because if you remember when we did the configuration, I had set one line called push.default is simple. So that is what it is going to help here. So that literally means that every time when you create a new workspace.
Say that again, Adams.
So when we use the configuration, that is what I'm trying to say. So typically when you're trying to create a repository or clone a repository, it stores all the information from where it has created. Okay, so if you see, we had this central repository, right? And then we had our own local repository, right? So now from where was this local repository created? The local repository was cloned from the central repository. So that is the reason it stores all the information about this central repository. And when you give the option called push.default is simple, so without even we saying to which central repository you have to push, if you just say push, it will automatically know that, okay, the push.default configuration is put into a simple mode, which means if they don't say anything, then logically I will put the information back to the central repository from where I was created. Okay, so in that way it will automatically go back to the central repository from where you had created that workspace or repository. So that is how when you do a push, it will automatically.
Adam,
Yes.
your voice is breaking up, so I just wanna mark it.
Can you hear it?
Yes.
Yeah, so as I was saying, by default, if you set the configuration as simple, then without even you saying that where you have to put the data, if you say git push, it will automatically go back to the parent repository from where it has created its workspace. Okay, so that is how when you go inside the central repository, I am able to see everything. Is that clear?
Adams.
Is that clear?
Yes, Adams.
Yes, sir. Actually, I want to ask you a question.
Yes, please.
Sir, I want change the master repositories or that central.git repository. Where from I can change?
What do
Because
you mean
this
by
is a
changing?
default. Because
Changing.
that all are yes, because that all are by default settings. So I want check that where from we can change that central.get is there, and that is a permanent directory for that uh, our working space. You can say that,
Mhm.
and I want change my working space once more, and I want change the master directory. There is also no master branch.
No, you cannot
So
change something like that. So typically, you cannot create change the origin from where you have created, right? Because you need an origin. You cannot just modify it, but you can specify to where you want to push the data. So that is what I was saying. So instead of saying git push, you can always say git push and the specific repository name where you want to share the changes. So logically, this can happen, but you cannot modify the origin of this particular repository. So what is the origin of this? It is central.git. So if you have to modify this, it is not like a simple text format where you will be modifying. All those information what you were trying to say will be present in the .git. So if you go to this, it would have stored all the information here and through which it is trying to know. So instead of changing the origin of this repository, you can choose to which repository you want to share the changes or push the changes. So that is an option that you always have. So in Git, you use this option called git push. Okay, so say git help and the command name, it will try to give you the option. So here you can say whether which repository that you want to put. Suppose if you don't say which repository you want to put, then by default it will take the origin from where it was created. Okay, so instead of erasing it completely, you can use option through which you can push it to different repositories based on your need. Is that clear? Hello? Hello? Okay.
Adams, can we stop today's class here? It's like
Yeah, I'm
it's been
just
like very long day for me. Like
I'm just about to stop now. Anyway, it's just another 2 minutes. So if you see now what we did, we put the changes, everything into the central repository, right? So typically, this is what you will be doing it to share the changes between different repositories.